Hey guys, this is separation of variables and differential equationist day 3. So, in the past, we had always had directions that said find the general solution to the differential equation y equals f of x, or sometimes not. But now, it says find a particular solution, y equals f of x. So we still have this y equals f of x thing, with the initial condition, y of 0 equals 2. So remember that thing I was telling you about where there might be a whole mess of functions that satisfy a given differential equation that maybe looks like this or something? And as long as they have the same slopes, which they don't, because I'm terrible at drawing these, but you know, you can move this up and down. It'd be like y equals f of x plus c. So, you know, something with x's and then a plus c, and you don't really know. But now what you're doing is you're saying, well, I know that y of 0 equals 2. So, you know, y of 0, so if you plug in 0, that if you plug in 0, you should get 2. And since this is a function, there's only one. There's only one way to do this. And so that would be like that point here, if that's, you know, 2 on the y-axis. And so then you know it must be this one, and that's your particular solution. A particular solution equals a function of x that's specific. And a general solution is a family. So the general one is a family of solutions that all have some constant c in them. But the process for beginning these is exactly the same. So we're going to separate variables. Okay, so he's just highlighting these differences here. So now, just separating variables, multiplying the dx over, dividing by y minus 3, integrating both sides. Pretty standard integration here. Doing that thing with the e's again. And then, if this doesn't make sense, go back to the other video, the last video, because I justified a lot more there. But that's not really the point of this one. So the e and the ln sort of die, and you're left with something that I should most certainly erase, because I'm getting all in the way here. So essentially, we get y minus 3 equals some constant 2, because remember, we're just bringing this c down in front of here because we can view e to the 1/3 x cubed plus c as equal to e to the 1/3 x cubed plus, or sorry, times e to the c. And e to the c, that's just something we can call c sub 2. And we just put it out there in front, since it's kind of odd to have e to the 1/3 x cubed times 2. So, or times c sub 2. And so we have this here. So we have this equation. We're moving our 3 over, but it still has this thing in it. So now we need to make sure that this is true also. Not only does dy dx have to equal x squared times the quantity of y minus 3, but y of 0 also has to be 2. Well, we can just plug in 0 for x and 2 for y and solve for c. So this is like so, plugging in 0. E to the 0 luckily is 1, and that happens a lot here. A lot of the time when you have an exponential function, your initial condition is 0. And so that's usually a very good thing. 2 equals c sub 2, since this is all just so this just all turns out to be 1 here. So that's just c sub 2 plus 3. And then c sub 2 is minus 1. So then what we can do is we can plug in for c sub 2. And, you know, there's a minus 1 hanging out right there, even though you don't see the 1. And this is your particular solution. And he's saying that you must check your solution in your particular solution. And so all that's saying is plug in 0 for x and make sure you get 2, which he does over here. And I should erase this now so you can read it. So plugging in 2 for y and like such, and 2 certainly equals -1 plus 3, and so that gets the check mark, and you're good to go. Another one here, same directions, y of 0 equals -3, and in case it wasn't clear, y of 0 is just another way of saying f of 0, since y equals f of x. Separation, so highlighting that stuff again, separation of variables by multiplying, by cross-multiplying basically, just like that. And now you'd probably, let's see, I'm going to guess he's going to multiply by the 2's here. You have to clear things up. But multiplying by 2 changes the constant. And sometimes you would write c sub 1 when you go from c to something, or sometimes you would write c sub 2. It really doesn't matter. You'll see both, and there's not really any reason to concern yourself with keeping that notation consistent, because it does mean a different constant, and that's the part that matters. And then taking the square root of both sides, only since it asked for this particular solution, y equals f of x. So we got this particular solution here. And you got to get that plus and minus in there, even though it's sort of awkward. Now, to solve that, we're going to plug in 0 for x here, and -3 for y here, just like that, and solve for c, probably squaring both sides. -3 equals plus or minus the square root of c, square both sides, c equals 9. So, okay, so this is an important point, and this is something that you can easily lose a point on an AP test or any test. So we've got this thing where it says, we got this plus or minus, and so is it a plus or is it a minus? It can't be both. So what this is saying is, okay, when you take the square root of anything that's not a negative number, the graph of square root of something looks sort of like that, and so that's always positive. But what this is telling us is that y of 0 is -3 here, is -3. And so in order for that to be the case, there has to be something going on below the x-axis, which means that this square root, because whenever you take a square root, it's going to be positive, so that means that, after the fact, you have to flip it to a negative in order for this to satisfy it. Otherwise, you're getting like the reverse solution of it, and that's not what you want. So if you ever have a plus or minus, pay special attention to make sure you think about it and what makes sense in order to get your very specific particular solutions. In a particular solution, there will be no plus or minus nonsense going on, because that's not very particular. And hopefully that was helpful and gives you a good introduction to separating variables and solving both general and specific differential equations. Oh, there's another one. Okay. One more. So we've got a whole bunch of stuff here, and in this case, instead of saying like dy dx equals something, we just already have the dy and dx spread out, which is fine, so we need to get these dy's and dx's apart. And my first instinct would be to subtract this giant mess over, or subtract that mess over, and so that mess is getting subtracted over to this side, so you get a minus, and you got this, and then we have some x's and y's multiplied here, and x's and y's multiplied here, but we need them to be, very specific, and have it only be that. So we get this, which looks hideous, but we'll probably simplify some. So only dy's, only dx's. Okay, so yeah, simplifying that, y squared over y is y, and minus 1 over y is minus 1 over y. And also just turning that into a positive exponent, since having a negative exponent in the denominator is very redundant. All right, doing that, integrating. Integration, use substitution, you're correcting for that chain you get with your 2 and the minus there. Let's see here. Okay, so when you integrate that, 1/2 y squared plus ln of absolute value of y equals minus 1/2 e to the x squared plus c. Let's see what changed here. Oh yeah, he just multiplied through by 2 to clear those 2 1/2. So instead you get the y squared plus 2 ln of y minus just e to the x squared instead of the 1/2. And you get a different constant since you have to multiply that one. And you can put c sub 1 there if you want to do also. Now our initial value. Oh, and the other thing is that it did not say y equals f of x. Thank goodness, because I don't know if you can even solve that as a function of x. You certainly can't. So we're plugging in our initial value, and we get 1 squared plus ln of 1 is 0. You'll know that if you don't already. 0 equals minus e to the 0, which is 1, so minus 1 plus c. c2 equals 2. And we get y squared equals 2 ln of y equals minus e to the x squared plus 2. And we're just using one of our logarithmic rules. So we can pop that exponent up there. And let's see, at this point, let's see the ln. At this point, this ln, I think, should probably still have an absolute value there. I could be wrong. But then once you move that up there, you can still see. Well, no, it doesn't need it there. It needs it here until you've verified that. But having a 2 there, or you can at that point you would have realized that you don't need it anymore. But it's a little more compact to write it as the ln of y squared. So once again, you do not necessarily need these absolute values there, since since it's implicit that 2 is going to hop up. But you definitely do not want to put absolute values there. Otherwise, that is showing that you do not really understand, why or why not you need absolute values. Putting absolute values on ln's everywhere is, sometimes it's necessary. But if you put it there and it's not necessary, that's showing that, you're giving, an opportunity to show that you don't know what's going on. And you don't want to do that. So know what's going on and only have them there when you know you need them. Be sure you use subscripts with C sub 2 and whatnot, and plug in for the constant. And that is it. So hopefully that was helpful.